Hello everybody, myself Jyoti and this is first lecture of transient response of circuits. We know that resistance, inductance and capacitance are the basic components of any electric circuit. So when the source is switched on, in general, the current in the circuit does not rise to its steady value instantaneously. Similarly, when we switch off the circuit, that time also the current does not become zero instantaneously. So why this is not happening? There is opposition to the growth or decay of current in an electric circuit because of two components. One is inductance and second is capacitance, and that is the reason why current does not reach its steady value or reach to zero value instantaneously. During the time of growth or the time of decay, whatever is the steady value of current, that is called as transient current in the circuit. Now let us take the we will focus first on resistance. When the source is switched on, the steady value of the current V upon R is reached instantaneously. So basically, right now what we are taking a battery which is connected to resistance. So when we will switch on the source or switch on the battery, that time the steady value of the current V upon R is reached instantaneously. There is no time lag. And when the source is switched off, the current drops to zero instantaneously. This is happening when we have pure resistance circuit. Now suppose we have an inductor and we have applied a battery to the inductor. Now when a current I flows through a coil, an axial magnetic field is produced in the coil, and hence a flux phi is linked with the coil. This flux, it is proportional to the current. So flux is proportional to current I, and if we remove the proportionality sign, we will get phi equals to Li, where L is constant of proportionality, and that is called as self inductance, or simply it is called as inductance of the coil. uh, so this L, that is the inductance of the coil, it depends upon number of turns per unit length. Second, area of cross section of the coil. And third one, it depends upon the permeability of the medium on which the coil is wound. If current increases or decreases, then the flux linked with the coil also changes. The rate of change of flux gives rise to an induced EMF E, and this induced EMF, it opposes the current, the change in current I. This induced EMF E, it is called as back EMF. So we have a E, it is equals to minus d phi upon dt, and we know that phi, it is L into I. So we can, and as L is constant, we can take it outside the proportionality sign. So we will get E equals to minus d phi by dt equals to minus L di upon dt. This induced EMF is nothing but the back EMF. Now when the DC source is switched on in a circuit containing an inductance, the current starts rising from zero. The back EMF opposes the rise in current and hence does not allow the current to reach its steady value instantaneously. Eventually, the steady state is reached di by dt, and hence the back EMF becomes zero and the current in the circuit becomes equal to V upon R, where R is the resistance of the coil. When the circuit is switched off, the back EMF again delays the current in acquiring the zero value, and SI unit of inductance is Henry. Capacitance. When the source is switched on, positive charge flows into plate A and negative charge flows into plate B. This causes a current to flow in the circuit, and this current is called as charging current. Why capacitor does not get charged instantaneously? We know that in case of inductor, the current in the inductor, it is not rising to its steady value instantaneously because of the presence of back EMF. So what is happening in case of capacitor? The charge already present on the capacitor at any instant opposes the newly approaching charge. Because of this, the capacitor does not get fully charged instantaneously. Eventually, when the capacitor is fully charged, there is no further flow of charges to the plates, and hence the current becomes zero. Charge on the plates when the capacitor is fully charged is Q, and it is given by Q equals to CV. C is the capacitance of the capacitor. At any time before the capacitor gets fully charged, the potential difference across it is given by the formula C equals V equals to Q by C, because we have C equals to QV, so V equals to Q upon C, and SI unit of capacitance is farad. So today what we have learned, what is happening in case of resistance, capacitor and inductor when we up supply battery to individual components. So we know that in resistance the current rises to its steady value instantaneously, but in case of inductance it is not happening because of the back EMF, and in capacitor it is not reaching to its the charge is not reaching to its steady value because there is already charge which is there on the plates. So thank you so much.